Alright, today we're going to be talking about quadratic transformations and translations. We've already done exponential, we're going to work backwards to quadratic, and eventually we'll get to linear. One thing about quadratics, when we didn't talk about them earlier, was the vertex form of a quadratic equation. This is the vertex form of a quadratic equation. Y equals a, in parentheses, x minus h squared plus k. There's that h and k again, talking about the vertex. H and k is the vertex, written in vertex form. We use the letters h and k to represent the vertex. Alright, when we're talking about transformations from the parent function is y equals x squared. That is the parent form of the quadratic equation. Alright, so that's all the basics that you need. First example, jump right into it. We have y equals x squared minus 2. Alright, when we have x squared minus 2, we're going to be asked to find the vertex, axis of symmetry, and describe the translation from the parent function, which is that y equals x squared. To find the vertex, this is written in vertex form because I have x squared minus 2. If I just look at that function, I can see that the only difference between that function and the parent function is there's a minus 2 at the end, so I can already assume that it's going to go down twice. So my vertex, the parent function, normally on a graph starts at the origin. Now it's being shifted down twice, so it's going to go down twice. All the other points stay the same. The shape of the parabola stays the same. It's just being shifted down twice. The axis of symmetry is also staying the same. It's on x equals 0, which is also called the y-axis. As you can see, there is a line of symmetry going down the middle of this U, smiley face. That is your axis of symmetry. Okay, so when x is equal to 0, it is on the y-axis. That's just another reminder. Describe the translation of the y equals x squared. Again, we've already talked about this. It is being shifted down twice because the parent function normally is graphed starting from the origin. So if I look at the vertex itself, not the maximum, but the minimum point on this graph, the vertex has been moved down twice, and I know that that's because of this minus 2 at the end. That is the k value. The minus 2 is the k value that tells me it goes down twice. Okay, so that is all the first example. Next example. We have y equals parentheses x plus 1 parentheses squared. So inside parentheses you have x plus 1 squared. Again, this is based off the parent function y equals x squared. Your vertex has been shifted to negative 1, 0. That is the vertex now. The original, again, was 0, 0, but now it's been moved over to negative 1, 0. That's the vertex of this U. The minimum point is on negative 1, 0. The axis of symmetry. Okay, the axis of symmetry always goes through the x point of the vertex. Well, if I look back at my vertex, the x coordinate was negative 1, so x is equal to negative 1. I could draw a line down the x point at negative 1, and that has an axis of symmetry. The word symmetry means to have the same on both sides. There is a u, the half of u on both sides. If you don't know what the word symmetry is by now, please go look it up, because that is a elementary concept that you need to know. A symmetry talks about same things on both sides. I draw a line down the middle of that negative 1, and it is the same thing on both sides. Describe the translation of y equals x squared. It is being shifted left twice. So if I erase that, you can see that the graph originally starting at 0, 0, the vertex starting at 0, 0, it has been moved over left 1. And you can see that in the vertex. You could also see that in the axis of symmetry. So by all those things and the picture of the graph, you can tell that it has been shifted left 1. Now if I look back at my original function, which was x plus 1 squared, it's the same thing when we were talking about exponential functions. When things are in parentheses, it is the opposite of what you may think. Because this is x plus 1, your brain might think that it's being shifted to the right one time. But because it's in parentheses, it's actually being shifted to the left. And you can see that here in the graph. You type this in y equals on your graphing calculator, your graph is going to look like this. It's not going to shift to the right, it's going to shift to the left one time. Okay, so that is another example. Alright, this is an example. Those two things, those previous two examples were written in vertex form. This is written in standard form, where we have ax squared plus bx plus c. This is the one that you're probably most comfortable with, but it's a little trickier to find the vertex and axis of symmetry based off of it. Okay, if we go back, we have y equals x squared plus 4x plus 1. If we go back to when we were taking notes on quadratics, we went over how to find the vertex by hand. We used the formula for the x coordinate of opposite b over 2a. Okay, so if I use what I know off of this function, opposite b over 2a, I have the opposite of 4 over 2 times 1, because the 1 is in front of my x squared. That gives me to a negative 2. So my x value is negative 2. I can plug that part into my vertex because I know the x coordinate is negative 2. But to find my y coordinate, I need to plug this negative 2 into this whole function, which I did below. So I have negative 2 squared plus 4 times negative 2 plus 1. That gives me, when I just multiply that out and add it up, I get negative 3. So that negative 3 is part of my y coordinate. That is the whole vertex now. It's negative 2, negative 3. So the vertex of this, which is a minimum because it's a positive x, it's not negative. Which, going back to those notes, remember maximum has a negative in front, which makes it a frowny face. If it's a positive, it's going to be a smiley face or a U shape. So I know my minimum point is at negative 2, negative 3. Alright, so then the vertex, or the axis of symmetry, I just look at the vertex where the x coordinate was, which was negative 2. So on my graph, I know there's a line going down the x value at negative 2 to make both sides the same. Okay, you're just splitting it in half to make both sides the same at x equal to negative 2. Now, to describe the translation of y equals x squared, this is still the parent function. Even though it's not written in this was not written in vertex form, this is still the parent function. So to describe the translation, it is being shifted left twice and down 3 times. So based off the parent function still starting at the origin, the vertex starting at the origin, I could count from this vertex to this vertex. It went left 1, 2, and went down 3 times. Okay, so you just use the vertex to count your shift when you're doing translations and transformations with quadratic functions. Just like we use the initial value for exponentials, we use the vertex for quadratics. All right. Now, this last example, it is written in vertex form. It is y equals x minus 2 in parentheses squared plus 1. You are going to find the vertex. You're going to use the vertex to help you find the axis of symmetry, and then you're going to describe the translation of the parent function, which is y equals x squared. This is written in vertex form. If you need to graph it, you can graph it. If you already have a graphing calculator, you can type that in and count. It's very hard to do that, but I suggest you find the vertex, which will be the easiest way to describe the translation of y equals x squared. So that is what you're going to do on your own. Flip back to the previous examples to help you out, and you can look back at the notes of the very first slide if you need any more help.